So my name is Alex Don. I'm with AT&T and I'm a developer evangelist for the AT&T developer program. I actually started hackathons for AT&T, and you can find all of our programs online at developer.att.com/hackathons. So if you're interested in attending more, we run them year-round, for better or for worse, every weekend. We've got a lot of miles, not a lot of life on the weekend. But I love technology, and this is what I love to do, right? And so I actually happened to meet up with Brian a while back, and we were like, oh, let's do a hackathon for SIC. This would be pretty cool. And what about wearables? And like, oh, check out these kitty ears. Like, what can you do with the cat ears? And Plantronic headsets and all this stuff, right? So after we started kind of ping-ponging back and forth ideas, it was awesome. So that's how we ended up here. And this last weekend we ran the hack, had a ton of great people show up, even non-technical, some of that, a lot of different talent came out, right? So non-technical and technical, and hopefully you'll see a bunch of the different teams today and kind of see what they did to pull it all together. And the teams will be around afterwards for you guys to ask questions, so don't be afraid, talk to them, they're all along the side. Actually, if you guys want to raise your hands for the different teams, those are all the different teams over there. So we brought in a bunch of different companies, so embedded systems, Plantronics with the headsets, NeuroSky was there with the kitty ears. There's a Bluetooth version of this that actually just ties directly into your laptop and or app, which is pretty cool. And then we gave the developers 24 hours to iterate through the different ideas and come up with the product, and they did a fantastic job. So here are the 5 teams we'll be introduced to in a tiny bit. But first, I'd like to introduce you to the judging panel. So let me go first to you.
How would I use this?
Excellent.
Hi, I'm Hanson Hosein. I'm director of the Communication Leadership Program at the University of Washington. Specializes in digital media and communities and networks. We actually talked about wearables in our class on Saturday, and I'm putting in a plug for my 4 p.m. panel today.
My name is Ieong. I work for Cobalt. We do the digital advertising for the automotive industries. That's what we do.
My name is James Whittaker. I am a distinguished technical evangelist for Microsoft. I used to work for Google. I was a professor for a while, did my own startup. And I just want to know, are those cat ears, or are you just happy to see me, Alex? And I'm speaking tomorrow at 11:30.
Hi, everyone. I'm Rebecca Kaden. I work with Maveron. We're a venture capital firm based here and in San Francisco. We fund direct-to-consumer companies in early stages, including a bunch of hardware stuff. So excited to do this.
I'm Michelle Goldberg. I'm a partner at Ignition Partners, also a venture capitalist, and very interested in the space where technology meets fashion and retail, and wearables is the next generation of technology there.
Fashion?
And I'm John Cook. I'm the co-founder of GeekWire. We're a technology news site based in Seattle, and I'm also interested to see what everybody produced for the hackathon.
Oh, I'm also L Gold, if you want to tweet me during the second feedback.
Yes, please tweet. Make sure to use #SIC and hit the hashtags. So just to kind of give the framework for what's going to happen the next hour here, the judges will be judging based upon standard criteria of polish, presentation, technical competence, and then creativity as well. So they've got their clipboards and pens, and they'll be scribbling away. And out of the 5 finalists, the judges will be deciding the top 3 places, and the top 3 places will be announced tonight at the party over in the Sky Bridge. So that's incentive for you guys to come. All right. So without further ado, let me hand it over to Tigvi, and he will announce the different teams to come on up.
Yeah, hi. My name is Tryggvi Lárusson. I'm the CTO and co-founder of Green Cloud, which is an Icelandic cloud provider. And we're here in Seattle because, because we're announcing today actually our first availability zone, data center availability zone outside of Iceland, and it's going to be here in Seattle. So we're really excited to be here. So I'm going to announce the teams that are competing in the hackathon. So first up is Gold Physics.
Okay. So my name is Dr. Joan Jasic, and these are my partners, Roger Hosko, right here, and Arnab Verma. And our product is Goal Physics. So our goal at the hackathon was to help athletes have breakthrough performance with big data, not drugs. So, next slide. So what any athlete knows is that training is everything, right? So when I compete, I ask myself, how can I be stronger, better, and faster? And it turns out there is an answer. And the answer is integrated analytics. What we're talking here is digital analytics that provide big data in real time about my performance with wearables. Now, pros use this. So what they call digital analytics and the effects, its methodology is called the optimization of marginal gains. So a sum of small improvements pays off. So what sort of analytics are we talking about? Now, here, if you look at this slide, you see the US women's cycling team. Now, if you're a pro, you do all sorts of neat things, like you measure your circadian rhythm. And what you do is you buy a water-based mattress pad, and you set that to an exact temperature somewhere between 64 and 68 degrees every night, so that you can regenerate the human growth hormone. Again, science, not substance, okay? And if you're the US women's cycling team in 2012, you go from 12th place in the world to 2nd place in the world when no one thought you would even place. So there's evidence that this works, and it works really well. I'm not a pro cyclist, but I am a recreational soccer player. And I take my training very seriously. So what can I track using wearables and big data, right? So, oh, sorry, my emotion. Okay, so one thing I can track is my emotional performance. So maybe I feel very anxious when I have a public game. And what I want to do is track my mental state over the duration of the game so I can identify spikes in my anxiety level, right? With this sort of technology right here, tracking my mental waves. And what I can do then is go back home and see, okay, well, I get really anxiety, a lot of anxiousness as soon as I step onto the field. And what I can do then is to use visualization techniques and mindfulness training to really calm myself down, right? Another thing I can track is I can track parts of my physical performance, like my head orientation. This is very important for soccer players. So the trajectory of the ball is directly related to your orientation of your head. You know this if you play soccer. So if I'm shooting the ball, I want to keep my head below a 90-degree angle. So maybe I can track the extent to which I lift my head above those 90 degrees. And I can be mindful, really, really careful about keeping my head, lower when I'm shooting, for example. So another aspect I can track is my shot power, right? That's crucial. And I know that I get the most power when I kick on the first metatarsal, right? But I know that when I practice personally, I don't have a lot of data. It's just this empirical, seeing where the ball flies and trying to remember where I shot the ball. But if I could have real-time data about where the ball was hitting my foot and how much force that was creating, I could build that back into my training program and get better, stronger, and faster, much quicker. So the key for us here today is, remember we had this question, how can I be better, stronger, and faster? The answer is these integrated wearables and big data. So it's a multi-sensor approach. And what I have is a library of data that I can mine and tailor my training practices according to my needs. So let's take a look at what this does, all right? So now I'm going to show you in real time what this looks like. I'm going to demo this for you. And Arnab's going to walk us through what the app that we developed in, 48 hours.
Thanks, John. Hi, I'm Arnab. So I'll quickly run you through the stuff we built over this weekend. So this, as you can see, it's like a normal web UI. We call it goal physics, and the general idea is you can basically train for these soccer things. And because it's a concept, you can also do stuff with baseball and stuff if you want to. So the way it works is you start a session, end it. So this, right now, what I'm demoing is static data which we collected during the hackathon. So you start a session, you end it, and then you can go to analyze it. Now, so on the right side, you can see the numbers that Joan had. And on Saturday, we actually did fly Beckham, Messi, and Ronaldo to Seattle, and we got their numbers. So you can see, right? They're pretty cool. So you can go check how Beckham did on a penalty kick versus what Joan did. And so these numbers are off from the NeuroSky sensor on her head right now. You can see meditation values and attention values. So basically how calm you are and how focused you are while you're actually shooting. So this is kind of the general idea. And then of that session, you can actually go drill down and have more detailed look at what you had. So how your head was oriented during the session and foot motions during the session. So this is kind of what you can do with this whole thing. You can record your sessions, go back, analyze, and do stuff. We also built in real-time tracking while you're actually tracking the thing. Let me go ahead and quickly start it up. So, Sean.
Okay.
I'll hand it over to Roger, and he'll explain you what this does.
Hey, go ahead and kick it off. See, make sure it works first before we start talking about it. So essentially what we did is that we wanted to monitor both the head movement and the foot impact on the ball. If you notice the first one, it'll show you roughly how the head is moving according to the person's stance. The second graph is showing the impact of the sensors when you kick the soccer ball. I want to say football. I suppose both of them are correct, depending on where you're from. But what we do is that this is being processed in real time. We're also streaming this data out to a MongoDB database. This allows us to be able to further analyze the data, import it into things such as Hadoop or different analytical tools to be able to study it over a period of time. This adds the benefit of not only seeing in real time, but going back and seeing how you've done over the last year. It's fairly good for guys that hacked it together in 3 days. So. We like to thank all the vendors too for loaning us the gear and giving us the help.
Can we ask questions?
No. Yeah. Okay. No.
Okay, thank you. Thanks. Thank you.
All right, thank you very much, Gold Physics. Really quickly, for the next teams coming up, we need to try to stay on schedule here. So we're going to have to, if you guys could come on up and set up your systems right now. The next team is?
Yeah, the next team is hackcouture.io.
So now you guys are seeing what actually happens at a hackathon, right?
Okay, you should have it now, right?
Give me some sort of signal.
Hello, judges. Hello, Seattle. So today, I'm going to be demonstrating a headbang-powered air guitar application.
I was afraid this was going to be a different kind of exam with that glove.
No, it's no medical stuff going on here. So we've, but before I demonstrate this app, first I'm going to tell you why. So my name is Adam Smith-Kipnis, and I'm a member of Team hackcouture.io. We've got a few other team members here today. We've got Philip Cast, we've got Aaron Weathers, and we've got Daniel Herrera. And so go ahead and go to the next slide. All right. So when we think of wearable computing, the first thing that we think of is seams, right? We've got things that are wearable, and we've got things that compute. And how we combine those things is really what makes wearable computing interesting. Now, the current situation for wearable computing is that on the left side, we've got, this is woven fabric, and on the right side, we've got old school computer memory. Now, why are these two things completely separate, right? What we want to do is we want to combine computing and wearable technology. So, computing is becoming a lot easier. We've got people working on creating exo laptops where kids can create their own applications. We've got people who are creating Raspberry Pis. These are microcontrollers that people can use to automate all sorts of stuff. Companies like Apple, Google, Amazon, all these companies are looking at ways for making computing a lot easier. However, clothing integration could still be made easier. And so what do? We made a glove. So in our glove, we've got conductive fabric triggers. So when we touch our fingers together, it recognizes gestures, and it sends a message over Wi-Fi to a mobile device that we can then interpret. We also have a Pebble watch with a QR code display on it that we created. And there's also a programmable RFID chip embedded in the palm. So I'll demonstrate that right now. So this is it's an Android phone. There we go. Oh, so as you can see, we just launched Facebook on the app. And let's see here. Yeah. Sure. We'll plug this back in. All right. Yep. So the entire glove is connected to Wi-Fi.
All right, there we go.
Yep.
This is what a hackathon is for, right?
Yep. So this is our pre-beta version of this. Keep in mind, we created this entire thing in about 18 hours, and we got some really good team members working on this stuff. So we've got the 4 fingers up here, and when each of these interacts with either the thumb or the palm, it sends a message to the Raspberry Pi that we are connecting over Wi-Fi to our iOS app that we created. So who is this for? A lot of people. First of all, developers, right? So there's a problem with, if we want to understand what we're doing with our gestures outside of the field of view of a camera of some sort, this is a way of fixing that. For people who have limited mobility, we are offering a way to have additional accessibility, right? So one of our team members has already been working on a 4-bit text input system. So anybody who's got one hand or only one hand available can have a full range of the entire keyboard. Gamers, right? Like we can see that this might be a Power Glove 2.0. Performers, robotics, there's all sorts of room for expression. We're really interested to see not only what we've suggested here, but as we create it as a platform, what are the things that other people can do with this, right? I mean, we've seen this with a lot of really cool platforms where people have created these platforms not knowing how the public would receive them, and they put that out there, and people started building on that in some really, really interesting ways. And we've seen that time and time again. So, yeah, without, the next element is thinking about how we've got the ability to turn this into a musical instrument, right? So the app that we created essentially detects individual chords, or detects these gestures as individual chords. And we've linked that through the iOS device to the Plantronics headset. Now this is a prototype headset, thanks to our friends at Plantronics for making this and loaning it to us. Yeah, I've got some heroic efforts by the, yeah, I'm ready.
All right. You're live.
All right. So, as you can see here, we've got some visual display. As I interact with each of my fingers, it lights up the sensors. All right. Now, when I select one of these, oh, is it not paired?
You might have lost the Bluetooth.
All right. So the Bluetooth device has gesture detection that's built into it. And what it does is it triggers those individual chords. So actually, if we want to pair this right now.
Yeah.
All right. Cool. So the thing that we created was a way for people to understand how to play the opening chords for Smoke on the Water by Deep Purple. And we were thinking about, as we were learning how to use this technology, it was sort of like learning how to play electric guitar, right? And how do we tell that story? And one of the things that people learn when they're first learning how to play guitar is the opening chords for Smoke on the Water. So we figured that would be a really good way of integrating this experience.
All right, we're good.
There we go.
Oh, we lost the Bluetooth, but we can do it from then.
Okay. So we've also got the ability to use the accelerometer with our app that's built into the iPad. We have two versions of this app right now. We've got one that's for the iPhone and one that's for the iPad. So if I select that right now. Yep, go ahead. Yep, I'll select the next one. Oh. So there's a lot of moving pieces going on here, but as you can see, we've got support for several different platforms. We want to create this as a platform of our own. So I know that we're limited on time, and so I was going to say, if we got any questions, please talk to us. We'll be around afterwards, so just come on over and find us. And thanks a lot for your time.
And no sore fingers when you fly.
Nope.
So next one up is surveillance for puppies.
Is Team Runner Groove here? Yeah. Oh, perfect. All yours.
Hello, everyone. Hello, fellow judges. Before I start, I would like to ask a question for all the judges. How many of you have dogs or love dogs? Have dog or love dog? Dog. Okay, great. How many of you have dogs or love dogs? Great. So during this weekend, we built a wearable device, not for human beings, but for dogs. Serious for dogs. Do you know today in the United States, there are actually more households with dogs than households with kids. Actually, for a lot of people, the dog is actually their kids. As a dog owner, I love my dogs, but I have a headache. Every time when I need to go vacation, I have to send my dog to the dog kennel or ask a dog sitter to take care of them. So actually, every year, I spend hundreds of dollars on dog sitting or dog boardings. Every time when I bring my dog to somebody else to take care, I keep wondering, is my dog really get well treated? Did they really walk my dog 2 hours a day? Did they get enough exercise, enough fresh air, or they just stay in the cage? So during this weekend, I have an amazing team. So we built a very interesting solution that hopefully to solve this problem. So what we built is an electronic dog tag. This is a tiny electronic dog tag that built in with a Bluetooth low energy chip. And we hacked it to support the Apple's iBeacon technology. So with this tag, we also built a mobile application. So this mobile application can talk to the tag whenever it is nearby. So it can upload interesting information to the cloud. Imagine that. If there's a dog sitter, he using our service with our application installed in their mobile device, whenever they are walking close to my dog, so the beacon from my dog's tag sending constantly will automatically trigger the mobile apps from their app. And then the mobile app will begin to log in some interesting data to the cloud. So when did they walk, the walking speed, where they walked, and even the route of the dog.
So the dog doesn't have to code, right?
The dog don't have to code. And most beautifully, the dog sitter only need to use our service. They don't need to open up the app to begin to log. So everything happens automatically in the background. That's all because of Bluetooth low energy technology, the beacon send automatically trigger the apps. During the weekend, we used a TI, a sensor tag, a dev board to develop the tag. I want to have a look. And also we developed the mobile application. I have 2 phones running our apps. You can have a look. The audience can see from the screen. So we actually have a beautiful app building. It's not just a mock-up. It's actually the real working app. Only 2 screens is working. One screen is sending the data to the M2X platform. The other screen is a dog walking route, which is a real data that is close to the place where hackathon take place. Thanks. With this application and this service, as a dog owner, I can not only log all the dog walking activities I have with the dog, but also I can check what my dog is really doing with the dog sitters. What is the dog doing with the dog kennels at anywhere, any place. In America, there are 47% of the household at least have 1 dog. So according to a report, there are actually $4.1 billion spending every year for dog sitting and dog boarding. This is a huge lot of money are spent there. Average dog owners spend $274 every year for dog sittings. Actually, I spend more. So there are so many dog owners, they actually like me. They are wondering, do their money get really used? Does their dog sitter really do their job? Our solution is exactly help to ease the pain of this problem. And I would like to, it's very interesting that during this weekend, we have a very interesting team. We have 5 kids. We have 2 kids come here. Can you please also come to the stage? We have 5 kids. They are creative kids. So we have great designers and great developers. And actually, our team leader is on the background. He's a dog. He's a 7 years golden retriever, but they don't allow me to take here. Thank you.
So next team up is Runner Groove.
All right. Can I get a hand setting this up?
If that mic was wearable, that wouldn't have happened.
You guys liking these presentations so far? Good stuff, huh?
Okay, my name's Alex Swan. I'm a web developer looking for full-time work. I make games as a hobby. I made this game here in this 24-hour period for the hackathon. It's called Runner Groove because I'm not very creative with names. What it uses is a Plantronics headset as the controller. I'll test it in a second. Why don't I just get through this? I use Cocos 2DX game framework to make an endless runner style game, kind of like Temple Runner, I think it's called, or Jetpack Joyride. You know, I've got inspiration from a bunch of things. I used animation from Spine, which is made by a company in Seattle. I used some graphics from another person that is based in Seattle here. Why don't I start this off? All right, so here's the headset. It's small, and it was pretty fun to work with. Yeah. Okay, so this is the Plantronics headset. It has built-in an accelerometer and all the information to keep track of its orientation. I put 3 different things into it. Let's start up the app so I can demonstrate. All right, so when I start, there will be a little dude on the bottom here. I direct him going left and right by turning my head, like so. I orient it by doing a tap like that, and that'll center everything. And then I also can jump from a little to one side to the other by tilting my head like so. Let's see, I've got to orient this over a little bit. Okay. So you move around like this. The levels are modular, which means that there's segments of maps, and it picks out which ones. See how I'm doing pretty good. I'm getting more practice. Okay, so that I can jump like that, and it just runs like so. I'll run into this on purpose just to. There. Okay, I didn't get all the objects, but okay, so I died there. That's kind of how it goes. It keeps score, and scores are uploaded using M2X to keep track of how far everyone's getting, and high scores can be put up. This was what I got for 24 hours. In the future, I can add enemies, more explosions, particle effects, make it flashy, and put coins to like make paths or anything like that. Online leaderboards are easily added, and since it's a Plantronics device, I can do voice response. So maybe if you cry hard enough, you can come back to life. So that's that.
You got extra points for that joke at the end. That was good. Wearable.
So next we have the last team. It's called Couch 2.0.
Should I recuse myself since he's using Windows 8? Judge, I'm okay?
All right, everybody. My name is Chinua, and the members of my team are me, myself, and I. It's a one-man team. I present to you Coach 2.0. My system is a game-changing hardware and software solution. Now I'm going to explain a little bit more about it in a few minutes. So our agenda for today is we have like an introduction, we have a problem statement, we formally introduce our system, look at the system architecture, look at some of the technologies that I used. We'll have a demo and have time for questions. So we'll start by introducing Alex. Alex is a college student. He's the first one in his family to go to college. Alex likes to play football, and he's pretty good at it. But something unfortunate happens one day at a football game in his senior year. He has a critical incident on the field. He's promptly carried off the field to the hospital. He gets to the hospital, and after running a series of tests, he's diagnosed with brain injury. This is 2013, and we still have such incidents in the United States. So let's just park that for a little while we move on. So you see that this is not an isolated case. Looking up Wikipedia, you can see that we've had more than 1,000 direct incidents and 683 indirect fatalities as a result of participating in organized football in the United States. Such numbers it's not just right. It shouldn't happen. More than 40,000 high school kids have brain injury as a result of playing football every year. I said 40,000, not 40, not 400. Recently, the NFL actually made a settlement with injured players to the tune of $765 million. That's more than enough to give everybody in this room $1 million each. Who wants $1 million? Oh, you also want $1 million? I could fix you up. So looking at all this, right? All these unpleasant circumstances of playing the game we all love. I'm glad to introduce to you my system that is called Coach 2.0. So Coach 2.0 is an automated metric tracking system. It's an application that helps coaches monitor real-time metrics of player performance. So it means that while the player is on the field, the coach can actually get, using my system, real data. The coach can know how far has this player run. The coach can know how many hits has this player taken. The coach can know how many times has this player fallen down. Because many of these injuries, they don't just appear from nowhere. There are signs and signals that we often ignore. And these things come back to bite us. And they bite us real hard. And I want this to stop right now. That is why I introduced to you Coach 2.0. And I must say that my system is not limited only to football. It could be used in many other sports, like hockey, like soccer. It can also be used in different industries, like defense and manufacturing. My system is actually online right now, and it's hosted on Windows Azure. So you can see a link out there. Yeah, I see the Microsoft man, yeah. All right. So next.
I've already scored you, man. I've already scored.
All right, so next, I just want to show you a little bit of what my system is made up of. So this is the system architecture of my system. So during the hackathon, I actually set this up in 24 hours. I had 4 systems, all sending data to my instance of my application in the cloud. And the data is sent to the cloud, it is processed in the cloud, and it's made available on a website that a coach or anybody who is interested can actually monitor this data. And so what it basically uses is a Plantronics headset. So it's this little piece of a device that is going to be put on each of the player's helmets, right? So when the player runs around, it can track the movement of the player. So how my system works is that it uses this piece of hardware. This piece of hardware sends data via Bluetooth to a laptop. The laptop has my client running on it. My client communicates with my servers on the internet via a REST interface. My servers in the cloud process this data and make it available. So talking about the technologies I used C# for my programming. Did I see the Microsoft man again? I used HTML5. And because I used HTML5, I don't need to come out here and be dancing that I have an iPhone app. I don't need to come out here and be dancing that I have an Android app. I don't need to come out here and be dancing that I have a BlackBerry app, because HTML5 runs on all the platforms. All right? Also, so my system uses a REST interface. It uses the Google Chats API. It uses the Plantronics hardware. It runs on Windows Azure. And so while I was building my system, I looked into using M2X, which is by AT&T. But apparently, M2X is not mature enough for the kind of data that I got. So I had to set up an instance of SQL Server on the cloud. So let's take a quick demo of this application that we're talking about. So just give me 1 minute to get, OK. So it looks like I have a good connection now. So what you can see here is actually my client that runs on a laptop. Oh, gosh. My mouse is kind of screwed up here. OK, so I'll just run it briefly so that you take a look and see what happens. So this is kind of just like a client. So this client, this piece of hardware connects to my client via Bluetooth. As you can see, when I shake the hardware, you can notice that the values are moving. So I have that plugged into my ear. And as you can see, when I look up, can you see the values? When I look down, can you see the values? Now, when I hold this out and I tap it, can you see that? It says 1 tap. I tap it again. It says 1 tap. I tap it twice. Can you see that? And then when I hold this up and I drop it, can you see free fall? I hold it up and I drop it. Can you see free fall? So this device actually picks up lots of these metrics. And now what this client does is that it picks this data and it sends it to the cloud. Now I'll show you a little bit of that. So each player has this on the field. Each of the players' instance is connected to a laptop and is sending data to the cloud. Now I'll show you what that looks like. And before we go very far, we remember Alex, right? So we'll go back to the Alex story just for a little bit. So, I have a power cable there. Can you please give it to me? I'm almost done. OK. All right. So here is what I have in the cloud. So you can see that this shows the coach the data, real-time data of the performance of his players. So as you can see from these graphs here, as you can see here, right? Look at Alex's performance against other players. It is obvious that after some point, Alex was not moving anymore. His performance was just flat. That was a clear indication to the coach that Alex should have been taken off the field at that point. You can also look at his viewing angle, right? You can see that all his metrics were just flat after some point in time. You can look at the distance that he had run. You can see that all his metrics are very flat after a point in time. And this is a clear indication that Alex should have been pulled off the field even before anything happened, right? So using my system, it gives coaches the power to make real decisions. It gives coaches it gives coaches the ability to make the right decision at the right time. And so that's that about my demo. If you have any questions, I'll be at the back, ready to answer your questions. I have a few references out here, just in case you want to verify any of the things that I've said. In closing, I would like to say that Coach 2.0 is not an app. Coach 2.0 is not a game. Coach 2.0 is not a fancy gadget. Coach 2.0 is a system that can save lives. Coach 2.0 is a system that can save us lots of injuries. Coach 2.0 is a system that can save us lots of visits to the ER. So I would like to enjoin all of you, everyone who is interested in making a difference, to come along and join me as we take Coach 2.0 to every football field in America. Thank you, and God bless.
All right. Thank you very much. So that pretty much concludes the presentations. Hopefully you guys have got some interesting insight into the tech that went on this last weekend, as well as the developers that develop these kind of applications, right? So a lot of interesting technology and different devices went into all these different things. One of the key things I kind of really wanted to, part of the reason why I let the presentations run on a tiny bit was it's really about the education for us, right? Like, I want to make sure that everybody kind of sees, you know, as a developer, one of the common jokes is you'd say, what time is it? They don't tell you what time it is, they tell you how to build the clock first, right? And so, you know, it's really neat to kind of peer into the minds of the developers and see what it is that they're thinking, as well as how the technology pulls together in the different ways to form their solution, right? So hopefully you guys had a good time. Give a big round of applause to the developers and teams, judges as well. Thank you much, and I think this will wrap it up.